Hey everybody, my name's Zach. I'm with Group 11, formerly known as the Burleson Boys. And as you can see, we had the statics project. So, in statics and this problem, you're looking for everything to be in equilibrium. So we want all the force in X and all the forces in Y to be equal to 0. So what we're kind of solving for is this tension of this rope in AC, tension of rope AB, and this angle theta when it's in equilibrium. So we as a group are providing this input D, LAB, which is the length of there, and then W, the weight of the object, as inputs to give you while we solve everything else. So to generally get this going, we'll start how we start all statics problems, essentially, and begin with the free body diagram, which just shows the forces acting on the problem. So right here we have that tension AC, tension AB, and the weight W bringing it down. So what's not part of this picture generally was that D value, which was this total distance between these 2 points. This is kind of where it starts beginning to turn into one of those max-min problems that we kind of did at the beginning of the semester, where we're defining one side of this, particularly this length of the AC, because we don't have it, and we want to make that an array of numbers. That way we can just solve it for a ton of numbers, and then we can pick the ones that suit our needs later on. So let's look at some of the general equations that will be used to solve these values. And just by taking a quick glance, you'll notice that both the angles are just 100% straight trig, just cosine of these sides with the lengths. Same with both of the tensions. This max LAC value is just Pythagorean theorem, and it's the max of what the length of AC can be, because we're assuming that it's a 90-degree triangle at this point, making it the hypotenuse. So that's where the Pythagorean theorem comes from there. The only other equation that's a little bit weird would be this LAC one, and we pulled this from the example problem that came with like the problem for this project essentially, and we just derived that into terms that work for us in this case. So that's what we used. So let's just kind of generally begin the algorithm of this code. That's what we're going to be generally doing to solve this. So obviously the first step is we're going to want to create that Excel or matrix input values to use all throughout the project that we're using in each case. So that's what we want to begin with, was just that data. Next thing we want to check that data. Each one of these is, or I guess two of them, are distances, and the third one's a weight. So none of those can be less than 0. So we want to make sure that that's not happening, and if it is, we want to fix that at this phase. Our third thing that we decided to do as a group in particular was convert it. The starting units for this are in feet and pounds, but metric just tends to be easier and more familiar at this point to kind of work with. So we decided to have that conversion in here, right? So that's not something you need to do, but it's something that we decided to do as a group. So now with these variables, this is kind of where we begin the for loop. And what we want this to do is, now we have a matrix of input values to test all throughout this. And so each row is like all three of the values that we'll be using. So there's a D, an LAB, and a W. So what we want this to do is go through row by row with each one of those and plug those values into our functions. That way we get an answer for that row, and then we want it to repeat and go on to the next row with all the new numbers and do the same thing. So that's the concept that you want to do for there, essentially. And then once you get all those values, it just comes down to the plotting. And we're just plotting those tensions against the lengths of AC, because that's what the project wants, and that's what we will give you. So let's run over to the code now. So I'm just going to show you our input values real quick. And as soon as this loads, the first thing, if you guys have this project, then you'll recognize that first low is that test value case that the TA sent out in that email. And obviously we wanted to make sure that that was a part of our own test case, because it's something to validate what we've done. And then down here at the bottom, we have a couple of those negative numbers, because we want to make sure that our validations are catching that and making the proper adjustments to make it work within the accepted range. So let's just start going through at this point. So here we're just loading that file, and we're breaking it into each column into its own variable so we can work with each one separately. We're creating a size now. We're going to need it later anyways to use for the for loop because you have to have the size. But right here, we're just using it to compare each row to a zeros matrix of the same size. So we make sure that each one of those values is not less than 0, and if it is, we want to take the absolute value of it to make it positive and usable. Our next phase was just our conversion. Simple. Then we begin our for loop. And because we're just doing it by rows, we're just doing one for loop. There's no nested for loops to our code. And right here at the beginning, we're defining that x value because that's the important one, because that one's the kind of thing that takes everything that was a single value into an array of values now. So we just did a linspace between 1 to the distance d that we were given, and we want 1,000 each, 1,000 numbers, I guess, to make this up. And then right here, we're just changing each one of the variables for the row so you plug into our equations a little easier. So right here, we're calculating the LAC. Have a quick another data validation in here to make sure that if to make sure that the LAV value, that length, is less than D. And if it's not, input a new one. So now we're calling into this function, so I'll go over here. And as you can see, all we're doing are the same calculations that we had on the prior page, just with the variables that we have now inputted into here and making sure that each one's to the correct row because we want it to change for each loop. We want new values there. So that's what's going on there. And then after that, we just have an output. And these guys right here are just the new matrices that are collecting each one of our values made from that function. And we want that so we can plot it later on. And then down here, here's that max LAC value that we're just doing versus the Pythagorean theorem. And we're just doing that for each one. So you get that max length that it is for when it's 90 degrees. And the same concept as right above is just making some new matrices to hold values made so we can deal with them. So now we begin the plotting, and this is, we just want it to go by row again because we want it to go down each one of the matrices that we just created and plot that tension against the length of AC. So that's what we're doing. The only kind of trick bit to this was we did these two variables right here, this E and F, and we did that so that each one of these figures is counting up properly. So this will be 1, this one will be 2, and the second time this repeats, it'll be 3. And that's how we decided to go about making sure that there's the correct number of figures and there's no overwrites of these figures. And that about sums up the code. So let's run this real quick. So a quick thing you'll notice as soon as it's run is that these tensions are all in Newton, still in metric, but we had this maximum length AC got put back into feet. We did that, one, because this value was to validate with what the TA sent out, and I guess we decided to keep that throughout to have consistency there. So here's our validation, picking up those negatives, so we got to make sure that those are now correct and in the proper range. And as soon as we fix that, you'll see now we have our 10 graphs of the tension AC versus the length of AC and AB, and it's just going to alternate all the way down for each set. Let's finish out this, make sure you get a glance at all of them. And that about sums it up. So I'd say as an overall limitation of our code would probably be right there at the end with our plotting, because each time we're doing it is just coming up with 1 per thing and per loop, I guess. And that's kind of like, if we added more values to it, it becomes really messy and there's just going to be a ton of figures there. And so I would consider that probably the biggest limitation of our code. And yeah, that about sums it up. Thank you for listening.